Derivatives of exponential and logarithmic functions. This will be the last video for chapter 3. Here's a list of formulas that you're familiar with. The derivative of uv, this is the product rule. The second rule here is the quotient rule. The third is the power rule, the derivative of a number times something with an exponent. And these last two rules we haven't used yet. They are on a sheet that you have already. The derivatives of trig functions, these are at the bottom of that list. So the derivative of the natural log of u is 1 over u times the derivative of u with respect to x. And the derivative of a to the u, in this formula, a is any number. The derivative of a to the u is a to the u. Times the natural log of a, meaning the natural log of whatever that number is, times the derivative of u with respect to x. This part here, the chain rule, means multiply by the derivative of the exponent in the original. We're going to do 6 examples that are on page 170. Exercise 6 says y equals e to the negative x over 4. Same as y equals e to the negative 1/4 x. The directions are to find the derivative of y with respect to x. Since e is a number, e is a constant, the derivative of a constant raised to a function of x is itself, the derivative of a to the u is a to the u, times the natural log of the number, the base, times the derivative of the exponent. So there's 3 parts to this. The derivative of e to the negative 1/4 x is itself times the natural log of this number, the base, times the derivative of this exponent. The derivative of negative 1/4 x is negative 1/4. So in simplest form, we're going to say the answer is negative 1/4 e to the negative x over 4. The natural log of e disappeared because the natural log of e is actually 1. The negative 1/4 that was at the end, I wrote that at the beginning. That's it. Number 10. Y equals e raised to the x squared. The derivative of y with respect to x. If a number like e is raised to a function of x, the derivative is that exact same thing, times the natural log of the number, the base, times the derivative of the exponent. The derivative of x squared is 2x. The final answer would be written like this, 2x e to the x squared. Just putting this at the beginning of the answer. Natural log of e does not need to be written because the natural log of e is the number 1. Number 16. Y equals 9, that's a number, raised to the negative x. When a number is raised to a function of x, the derivative is that exact same thing, times the natural log of the number, 9 in this case, times the derivative of the exponent. The derivative of negative 1x is negative 1. The final answer could be written like this. This negative at the beginning is from here. The natural log of 9 is part of the answer. And 9 to the negative x, we can write that as 9 to the x as long as we put that in the denominator without a negative exponent. And don't be fooled by, for example, number 14, y equals x raised to the 1 minus e. The rule that we just used does not apply because this base is not a number. So we're going to use the rule, way back on the list of rules here. The one we're doing right now is actually an application of this rule because it's u to the n. So this is more like, here's a different example, like 3x to the fourth. The derivative is found by multiplying this number and this number, the 4 and the 3. The x gets copied, and whatever the exponent is, we take 1 away. So we've done a lot of that. That's what this is. The derivative of y with respect to x is the number up here, the exponent, times the number here. 1 minus e times 1 is 1 minus e. The x gets copied, just like in that example. And whatever the exponent is, we subtract 1. Whatever the exponent is originally, subtract 1. The answer to exercise 14 could be written like this. X to the negative e can be written as x to the positive e as long as we put that part in the denominator. So 14 is not like 16. 16 is a number raised to a function of x. So is 10, a number raised to a function of x. So is number 6, a number raised to a function of x. But 14 is not. 14 is more like this example. Number 26. Y equals the natural log of 2x plus 2. The derivative of y with respect to x. So I'm going to look back at the list of formulas so you can see. You have the natural log of something. The derivative is 1 over the something. That means write 1 over whatever is here. And also multiply by the derivative of what I just put a box around. The derivative of the natural log of something is 1 over the something times the derivative of that something. So 1 times 2. This 2x plus 2 could be written as 2 outside of x plus 1. So the answer to exercise 26, in the simplest form, the derivative of y with respect to x is 1 over x plus 1. Because these 2's cancel. And number 28. Y equals the natural log of x squared plus 1. The derivative of y with respect to x. The derivative of natural log of something is 1 over the something times the derivative of the something. That's it. The answer to exercise 28 is 1 times 2x over x squared plus 1 times 1. This cannot be simplified.